Today we are diving into breakthrough idea in sustainable metallurgy, replacing coal and coke with biochar in steelmaking. This is not just an academic concept, it's a bold step towards decarbonizing one of the world's most emission heavy industry. Let's explore the science, trials, and future prospects of biochar in steel. Steel production contribute up to 7 to 9% of global greenhouse gas emission. Traditional reductant like coal, coke are high emission, costly and increasingly unsustainable globally, and here in India there is mounting pressure to switch to low carbon alternatives. That's where biochar comes in, carbon neutral, renewable, and circular. Now, how does biochar stack up against metallurgical coke? Fixed carbon, nearly comparable. Volatile matter, biochar higher reactivity is a major plus. Ash and alkali content, lower and variable, which could pose operational challenges but offer benefits in emissions. Cleaner profile make it a compelling substitute through process turning is this tuning is a key. Now coming to the technical part, so let's get technical. Biochar's porosity and BET surface area are game changer for combustion efficiency. Studies reveal faster burnout kinetics and superior gas solid interaction compared to coke. This property affect everything from fuel substitution ratio to furnace design. Think of biochar not as a 1 is to 1 replacement but as a smart fuel upgrade. Biochar is not a plug and play solution. It's need strategic integration. It can be injected into blast furnace tuyeres, blended into sinter feed, or partially substituted in DRI and EAF setup. Each route has its own perk and pitfalls, especially around burnout rates and alkali handling. But visualizing these insertion points in the steelmaking flow helps identify where biochar can shine. What do the trial says? Thermogravimetric test shows biochar burns quicker and cleaner. So quicker and cleaner is a big positive point with biochar. Its surface chemistry boosts reaction rates. Substitution trials using 10 to 30% biochar demonstrate very stable performance and significant emission reduction. So these two things it has, that the performance stability along with emission reduction. Heat maps from these trials visually capture faster burnout and thermal efficiency, making the case very stronger for a scale setup. Sustainability goes beyond emissions. Life cycle assessment show that biochar outperform coke across multiple dimensions. Let us see one by one. Lower CO2 across production and application, reduced land use when sourced from agricultural waste energy with carbon capture strategies. Chart comparing emission make it clear. Biochar is not just cleaner, it's smarter also. Here is where ambition meets reality. Pilot trials in the European Union, China, and India show promising results, but scaling is still very tricky. Cost factors include biomass collection, pyrolysis, and transport integration with CCUS and hydrogen based processes is promising. The takeaway, with supportive policy and careful engineering, Bachar could be a strategic tool for greener steel. So let's wrap it up. Bachar is not a silver bullet, but it's a powerful contributor to low carbon steel. Pilot trials are crucial. Supply chain mapping and cost analysis will guide a scale up and align with biomass policy, which can supercharge adoption. So, as we pursue net zero target, biochar